Hello everyone, good afternoon. Welcome to this next class of your fluid mechanics. In this today's class, we are going to continue your fluid mechanics, but now today we are having some practice questions, and these are the most important previous year questions of the GATE exam, which will be or which may be repeated in the upcoming GATE exam. So in GATE 2025, what questions we are expecting that will be again asked or that will be repeating from the PYQs, we are going to solve those PYQs. Okay. Today also you have also one more session at 7 p.m. on GATE wala ME XE CE channel for the same subject, fluid mechanics. So always remember, this is your English channel. So in this channel we are having the PYQs, the most expected PYQs this year, and at 7 p.m. we are also having the practice session or practice questions for the fluid mechanics again. Okay, so please do remember these two things. So now we are starting with a very important thing, that is the first thing, which is regarding the dimensions of the kinematic viscosity and the dynamic viscosity. So this type of question is generally asked. This type of question is generally asked in GATE 2014 also. They have asked the same question. They have asked in GATE 2014 also. Again for 1 mark. In civil engineering again for 1 mark. And continuously they are asking every 4 to 5 years this type of questions. Like they are asking the dynamic viscosity or kinematic viscosity dimension sometimes. Sometimes they also ask the unit of the kinematic or dynamic viscosities. Okay, so this type of question we are expecting to have. So first of all, you can give the answer of this question. Kinematic viscosity is dimensionally represented as. So just I am giving the poll to you. So 60 seconds I am giving, and you have options A, B, C, D. You can give the answer. ओके चलिए आगे बढ़ते हैं. अब यार कौन कौन से लोग चले आते हैं, बस फालतू में कमेंट करने ही चले आते हैं. बैड टीचर इन इंडिया. So who have told you to come in the class? Don't come in the class if you are not expecting as you want. So the students who are able to understand, they are coming. कुछ भी लिखते हैं आके. They are writing anything in the class. Okay, so let's come to the question. So in kinematic viscosity, always remember the unit is meter square per second, and for meter we have the dimension L and square is there, and for second we have the dimension T. Per second hand dimension T raised to power minus 1. So the dimension is L square T raised to power minus 1 or L square by T. So this question may be asked in the upcoming exams also, because they are continuously asking about the dimensions in every 4 to 5 years. So the correct answer of this question will be B part, kinematic viscosity. So all of the students have given the correct answer. Very good. Very good. Okay, so let us move to the next question. So one more question is there. Yes, this question. This is again the same type of question in which they are asking the dimensions. So always remember, every 4 to 5 years they are asking the dimension. In 2021 they have asked. In 2022 they have asked. Now from last 3 years they are not asking the dimensions, but in 2025, because 3 to 4 years have been passed now, so they can again ask the question of the dimensions. The dimension of dynamic viscosity. So they have asked the dimension of dynamic viscosity, they have asked the dimension of kinematic viscosity. This year they may ask the dimension of bulk modulus. This year they may ask the dimension of your let's say compressibility. Okay, so they can ask the dimension of these things. So again creating the thing, again creating the poll. You can comment the answer. Always comment the answer after I am starting the poll. Always comment the answer after when I am starting the poll. Don't comment the answer before that. So what is dynamic viscosity? Dynamic viscosity is represented by tau is equal to mu du by dy. So how can we calculate its unit? So you know that tau is represented in Pascal. Mu we have to find out. Du you will represent in meter per second, and dy you will represent in meter. So this will be meter. So this will be per second. Per second will be multiplied here. So this will be Pascal second. So Pascal second is the unit of mu. This is the unit. In Newton, you can represent it Newton per meter square into second. So Newton second per meter square you can also represent like this. Okay, when I will put Newton in kilogram meter per second square, because Newton is force, force is mass into acceleration, mass into acceleration is meter per second square into second upon meter square. So we will write this down as kilogram per meter second, because what will happen? This second square, 1 square will cancel out. This 1 square will cancel out from second, and this 1 square will cancel out from meter. So kilogram upon second and upon meter. So kilogram upon second upon meter means kilogram per meter second. We can also write it down as mu. So mu has a lot of units. Okay. In SI or in MKS also you can have a lot of units. Okay. So Pascal second is also 1 unit. Newton second per meter square is also 1 unit. Kilogram per meter second, this is also 1 unit. So any physical dimension may have multiple physical units. Any physical dimension, any physical quantity will have many physical units, but it will have only one dimension. Dimension is only in MLT or FLT. So in MLT, if you want to calculate dimension, it will come out from here, because this is in mass, length and time. So M into per meter means L raised to power minus 1, and per second means T raised to power minus 1. In MLT, this is the dimension. But sometimes what will happen in the exams, they will not give you the option in MLT. They can give you the options also in FLT. So let's consider how we will calculate in FLT from here. From here we will calculate the dimension in FLT. FLT means Newton we will write down in F. In FLT system, force is the fundamental quantity. So we will write the Newton as F. So F upon meter square means L raised to power minus 2 into T. So FL minus 2 into T, this is also 1 unit. This is an FLT system. Okay, so always remember, they may ask anything. Because dynamic viscosity is what? Dynamic viscosity is a dynamic parameter, means force related parameter. So they can ask you also the in FLT system. So dimension they can also ask in FLT system. So in MLT it is ML minus 1 T minus 2, and in FLT system it is L minus 2 into T. Are you getting my point? Because it is Newton per meter square into second. Pascal is Newton per meter square. So F L minus 2 into T is the FLT system dimension of your mu, dynamic viscosity. Dynamic viscosity is actually mu. Okay. So here it is asking in MLT, so it will be ML minus 1 T minus 1 D part. But if you will write down in FLT, FL minus 2 T. Okay. Always remember this thing. Why I have not given the kinematic viscosity in FLT? Because it is not a dynamic parameter. If any parameter is not dynamic, we don't represent it in FLT. We only represent the dynamic parameter in FLT. Okay. So dynamic parameter can be represented in FLT also and MLT also. Other parameters, geometric parameters, kinematic parameters or fundamental parameters will be represented only in MLT. I am going fast because I want to give more questions to you today. That is why I am going fast. So all of the students have given the correct answer, but it is not the session for you to ask the correct answer. It is the session to give you more understanding about your PYQs. Okay, so give you more content related to PYQ. So this is the session mainly for giving you more content in the PYQs, not for understanding that what the answer you will give. Everybody knows that this PYQ will have which option correct, because you have the answer keys with you. So we are not concerned about that what you have done correctly or not. Everyone will do 100% correct in all the polls. But main thing is that what content you should add in the PYQs. That is why we are going to do this session. I think I have told you this thing in engineering mechanics also and in RCC also. Okay, so we are just adding the content. The next type of question they will give you that match the followings. Also, I have told you this thing same in RCC. Please remember, same in RCC, same in engineering mechanics. I have told you, GATE has only 4 to 5 types of question in its basket. One is that it will ask you unit and dimension. Another, it will ask you match of the following. Another, it will ask you a statement type of questions. Okay. Another, it will ask you direct answer based questions. Like what is the definition of this thing? What is the equation of this thing? They are the direct answer type question. And at the last, they will ask you the numericals. Numericals are mainly for 1 mark and 2 marks. Statement based match the following are questions mainly are for 1 mark. Sometimes they also ask for 2 marks. Okay, so what you have to concentrate for 1 mark question, you have to concentrate more on theories. Why? Because in 1 mark question, they are asking a lot of theories. Okay, a lot of variance is there. Like match the following is there, direct answer type of question is there, unit dimension is there, statement type question is there. But in 2 marks, they are only asking the numericals. Okay, so what you have to concentrate if you want good rank now, if you want 10 rank, 20 rank, 30 rank, 40 rank, the rank under 100, you have to concentrate for 2 marks what you have to solve, for 1 mark what you have to solve. So match of the following generally ask for 1 mark. In 2016 they have asked this. So there are 5 curves. This is 1, this is 2, this is 3, this is 4, this is 5. Now they are asking to match the following, which is Newtonian, which is pseudoplastic, which is plastic, which is dilatant. I'm not concerned about the answer. Why you are commenting the answer? When I will start the poll, you will comment the answer. No worries. I have not started the poll. Don't comment right now. I have told you now, always comment when I have started the poll. I'm not here to tell you the answer of these questions. You know the answer of these questions, dear. Dear, you know the answer of these questions. Why you are giving the answers? One student is saying, sir, Hindi mein baat kariye. Do you know what is the name of this channel? The name of this channel, dear Mr. Shreshth, my dear student, this is the channel which is Gate Wala English channel. This is the channel for the students who want to learn everything in English. Okay, we have a separate channel for Hindi or Hindi plus English because we have different set of students. So for those who want to learn in Hindi plus English, that is why we have separate channel, Gate Wala MECEXE. So you know these things, guys. In GATE exam, everything will be English. I have not made the rules. GATE has made the rules. GATE will not give you the option in Hindi. Okay, so GATE has made the rules. So whatever the GATE has made the rules, I'm running about that. Right? Okay, I'm running behind that. Sir, I think clarity in sound is something low. No, Pushpa. No, Pushpa. Don't think that sound is low, because if sound is low, then everybody will say that sound is low. So I think you have some issue in your device. Please increase the sound or use the headphones, because if sound was low, then everybody will tell. Okay, and I also have some sound bar in front of me. I have some sound bar in front of me. It is in the range of more than audible, because if it is green, it is audible. If it is yellow, it is more than audible. If it is red, it is above audible. So it is red. Whenever I am speaking, it is going to red level. So it is more than audible. It should not be low. So let's understand what we have to learn from here. Okay. I'm not concerned about the options, dear. Only give the options as answer when I'm starting the poll. Please understand what we will learn here in this PYQ, what we are going to learn here. You are coming here to learn something. So don't give answers. Okay, if I am making this type of diagram, please understand, if I am making this type of diagram, this is the diagram of the ideal rigid material. Why this is ideal rigid? If somebody is asking, ideal rigid material is a vertical line in the shear stress and shear strain diagram. So what is the reason? If somebody is asking a theoretical question, ideal rigid is having vertical line. Why? Because whatever stress you will increase, it will not show any deformation. What is ideal rigid? Ideal rigid means, again the students are saying ABCD. Why you are saying ABCD? Everybody know the answer. Yaar. This is the PYQ. Whenever I will start the poll, then you can give the answer. I know that you are only concerned about ABCD. Jai Mata Di A part, Jai Mata Di B part, Om Bhole, Jai Bhole, A part, B part, Gate clear Bhavati, A part, Gate clear Bhava, B part. I know most of the students are there who will go to the exam. Om Pat Swaha C part, Om Pat Swaha D part. I know this thing. You are fond of this. But please understand, gate will not be cleared. You can only appear in the gate like this. You will not clear the gate like this. Please understand what you have to learn from the PYQs. Okay. So please learn a lot of things here. This is ideal rigid. Why? Because whatever the stress you will increase, the strain will not increase. This is your ideal fluid. Why? Because at very low shear stress, yes or no? At very low stress, the strain will increase. Continuously strain will increase at very low stress. So this is your ideal fluid. Ideal fluid. So one is ideal fluid. And all the remaining diagrams between ideal rigid and ideal fluid. Please understand, all the diagrams between ideal rigid and ideal fluid, all are the plastic fluids. I'm again saying all are the plastic fluids, because here one option is there, plastic fluid. So all of the diagrams between ideal rigid and ideal fluid, they all are plastic fluid. Are you getting my point? All fluids, all fluids are plastic. Okay, so plastic can be matched by any of the fluid. Are you getting my point? Plastic can be matched with any of the point. Okay, are you getting my point? Got it? राहुल बोल रहे भाई मैं जा रहा हूं, यहाँ पर टाइम पास हो रहा है, तो तुमको चाबी थोड़ा ना कोई मेरे पास है तो मैं ताले की, तुमको कोई बांध थोड़ा ना रखा मैंने, जाओ। ऐसे लोग चले आते हैं यार, जिसको रुकना है वो रुक रहा है, जिसको जाना है वो जा रहा है, कमेंट करने की जरूरत क्या है। एक मतलब भगवान भी मस्त लोग बनाता है, एंजॉयमेंट कर देते हैं क्लास में आके। प्लास्टिक फ्लूइड्स 2, 3, 4 and 5 all are plastic fluids. Now please understand, in plastic fluids there are two categories. One category is the type of fluid which are starting from point 0. One category in the fluid which are, no, Bingham fluid is not, Sudhanshu Ranjan, Bingham fluid is not plastic. Please understand carefully whatever I am teaching. I have told Bingham fluid is ideal plastic. You have removed that ideal word from there. So I have also told in the last class, one more thing I have also told, whatever I am teaching you, please don't remove any word or don't add any word. I have told this thing in the last class. Don't remove or don't add anything, otherwise you will be confused. I have told Bingham plastic is ideal plastic, okay? So now in all the plastic fluids, you have two types of fluid. One which are starting from 0, all the three fluids. Please understand very carefully, because you will not get these things in the exam. These three fluids which are starting from the 0 level, they are called as zero initial shear stress fluid. Are you getting my point? Zero initial shear stress fluid. Zero initial shear stress. ISS means initial shear stress, or we will say 0B fluid, or we will say zero tau naught fluid. Okay, zero tau naught fluid. Okay, zero shear stress fluid means tau naught, which is also B, is equal to 0 for these three fluids. Okay, in that which is a straight line, that is Newtonian, which is having increasing slope, that is dilatant, and which is having decreasing slope, that is pseudoplastic. Here also we are having three fluids. One, this, I will change the color now. This, and one, this fluid. All the three fluids are tau is equal to B is equal to naught zero fluid. This is the tau from them. This value is tau naught, or initial shear stress fluid. So these all the three fluids are called initial shear stress fluid, in which this one is rheopactic, this one is Bingham plastic or ideal plastic, and this one is thixotropic. But all are the plastic fluids. Okay, so these things you have to understand in this diagram. I have also told this thing in the revision session. Okay, now let's come to this. Newtonian is which one? Is 2 number. Okay, this number 2. Now pseudoplastic, which number? 4 number. This one 4. Okay, plastic fluid, any of these are the plastic, only one is not plastic. Okay, one is not plastic. 3 or 5. 3 is also plastic, 5 is also plastic. No worries, 3 or 5, anything will be there. So I will match this later. Whatever will be remaining, I will match this. Now dilatant is what? Dilatant is your number 3. So number 3 is dilatant. Now which is remaining? 1 is remaining and 4 is remaining. 1 is not plastic fluid, because 1 is ideal fluid. Okay, and remaining is 5. So 5 will be your plastic fluid. So 2, 4, 5, 3. No option is there. 2, 4, 5, 3. No, I don't think. There should be some option. 2, 4, 5, 3. Yes, 2, 4, 5, 3 is C part. C part is the correct answer. C part is the, yes, C part is the correct answer. C part is the correct answer. Okay, so now I am creating the poll. You can give the answer. Now you can give the answer. Now you can do in which you are very good. Now you can do the thing in which you are very good. Now I will see that there will be a line of comment. Now you can do whatever you are very good. In interview, if somebody will ask, in PSU interview, if somebody will ask, what is the strongest area of yours? What is your strength? Sir, A part, B part, C part, D part. Doing this is my strongest quality. And what is your weakest quality? Sir, understanding the question. Understanding the question is my weakest quality. Then interviewer will tell you, my strongest quality is show to the door. My strongest quality is show you the door. So I will say that this is the door. This is my strongest quality, to show the door to the aspirants. Okay, now let's come to the next question. Again, 100%. Always in PYQ session, always the answer will be 100%. That is why I'm not concerned about the polls. I'm concerned about mainly the adding the concept. Always add the knowledge. Always add the content. Whenever you are adding the content, whenever you are adding the content, then only you will be able to go far than others. You will be in the toppers whenever you are adding the content in PYQs. This type of question is again which one list, match the list again. So I will always solve two per set 2 questions, like 2 question dimensions, 2 question match the following, like this. Okay, so I'm starting the poll again. Okay, first give the answer, because a lot of students are fond of giving the answer only. Okay, so first give the answer, then only will explain. First give the answer. That is why, have you seen in the paid class? In the paid class, first I always start the poll. In paid class, I always start the poll first. It is my habit. I don't explain the question at first. First I start the poll, because you guys are very fond of doing this ABCD. So now here also I am starting the poll first, then I will explain. Give the answer first, then we will add the content here. Everybody knows the answer, I know. Everybody knows the answer, everybody will give the answer. Everybody will give the answer, I know. Everybody knows it. But the main thing is that what is important here? Important here to understand that what we can add there, the things here. Viscosity is the property of the fluid. But when the viscosity is dominant, the flow will be called as the laminar flow, and laminar flow is dealt with the Reynolds number. And the Reynolds experiment is also based on the viscosity. Reynolds number is the experiment. Reynolds experiment is also based on the viscosity. I have shown you in the fluid dynamics, that the Reynolds experiment is based on the viscosity. I have also showed this thing in boundary layer. I have also showed this thing in laminar flow chapter. A lot of chapter I have showed you. What is the Reynolds number? Reynolds number is, always remember, Reynolds number is Re, that is rho into V. V is the average velocity of flow, into LC upon mu, or VLC upon kinematic viscosity nu. What is LC? LC is the characteristic length. Most of the time, characteristic length is taken as the depth of the flow, most of the time, but not always. Like in open channel flow, Reynolds number characteristic length is hydraulic mean radius. If you want to calculate the Reynolds number, please understand, if you want to calculate Reynolds number for open channel flow, you have to put LC as hydraulic mean radius of the flow, not depth of the flow. But most of the sections, like in pipe flow, it is the depth of the flow. Sorry, it is the diameter of the pipe. But in most section, we take depth of the flow, but not always. Like in pipe flow, if the flow is pipe flow, because pipe flow is not laminar, pipe flow is mostly turbulent. Very small. 1 out of the 100 open channel flows are the 1 out of 100 of the open channel flows are the laminar. So in open channel flow, we generally take LC as hydraulic mean radius. I will also tell you this in the open channel flow in tomorrow's class. Tomorrow, I think there is a class of open channel flow. Tomorrow 6 p.m. in gate wala ME XGCE channel. Okay. So LC will depend upon the type of flow. In pipe flow, LC is diameter of the pipe, and in open channel flow, LC is the hydraulic mean radius. Okay. Next thing is gravity. Where the experiment is based on the gravity, means in a flow where the gravity force is the main force, there we generally calculate the Froudy's number, because Froudy has done the experiment of this. What is the Froudy number? Froudy number Fr is equal to the average velocity of flow V divided by root GLC. Again, LC is equal to the characteristic length. Again, LC is the characteristic length. Again, LC is the characteristic length. In open channel flow, characteristic length is not hydraulic mean radius. In Reynolds number, characteristic length is hydraulic mean radius. Please understand. In open channel flow, characteristic length is hydraulic depth in open channel flow. So characteristic length is not same. For Reynolds number, the characteristic length is hydraulic mean radius for the same open channel flow. But for the Froude number, the characteristic length is the hydraulic depth for the same open channel flow. So characteristic length may be different for different number. Okay, these things you have to add in your content. Okay, please understand. LC is equal to diameter of the pipe. I will write down this thing later. Okay, I'm not concerned here about ABCD. Please understand whatever I'm giving you. That will not be given anywhere else. Compressibility number. Whenever the compressibility is dominant means the density is changing. When the density is changing, density will come into picture. When the density is changing, the density will come into picture. Then you will use the Euler's number because density will come into picture. Yes or no? Euler number is actually 1 upon Ruark number, or sometimes we also say Euler and Ruark as equal. Sometimes we also say Ruark or Euler as equal. Euler or Ruark number we sometimes say, but actually they are the inverse of that. But scientists are using Euler and Ruark as the same formula they are giving. Okay, so actually it is P by rho under root P by rho upon the velocity of flow. But sometimes the scientists also use V upon under root P by rho, because everywhere the V is at the top point. So sometimes they take the inverse of that. So every time you can take under root P by rho or V upon under root P by rho. Anything you can take. Okay, because there is also one number, Ruark number, that is inverse of Euler number. So V upon root P by rho. So here density comes into picture because the density will change. Now, what is dependent upon the pressure? Okay, I'm sorry. This is not about the compressibility, because compressibility also connected with the Mach number. So here it will be pressure. For Euler number, it will be pressure. Why pressure? Because pressure is also there. So whenever the pressure and compressibility both are there, so pressure then you have to connect for Euler, and compressibility you have to connect for Mach. Because in Euler, compressibility and pressure both are there. So whenever you have to match, always match compressibility with Mach. Okay, guys, sorry for the delay. Actually, I had very important discussion. I have some issue at home, so I had call from my father. So I need to take that. Otherwise, generally I do not take in the class. Okay, so compressibility we have to match with the Mach number. Why? Because Mach number also has the compressibility. So Mach number is actually ma is equal to the velocity of object upon the velocity of sound in that medium. So if you are comparing the fluids with solids, if you are comparing fluids with gas, so what happens? The speed of the sound in gas is lesser, in liquids it is more, in solid it is very high. So what happens? So depending upon which is the medium, in which medium the flow is happening, and the velocity of sound in the same medium. Velocity of sound in air is generally 326 to 346, depending upon the temperature of the air. What is the density of the air? Depending upon that, 326 to 346. Now the velocity of sound in water is generally 1200 to 1400 meter per second, and in solid it is higher, even more higher. Okay, and that will depend upon the density of solid again. Main thing is that C will be high if the density is more. The main gist of that is that. So the pressure will be matched with the 3, because whenever the pressure and compressibility both are there, now you have to match pressure with the Euler number, because in Euler number pressure is also there. Okay, it also has the compressibility, but due to the pressure it is having the compressibility. And in Mach number we will add the compressibility. So 1, and now for the Reynolds it is 2, and for the gravity it is 4. So 2413, 2413. It is even in A part. So I think you guys have given this. That is given this. I am pretty sure that it will be more than 90%. Yes, it is 93%. Very good. Okay. Now let's come to other questions. We have done the match the followings. We have done the dimension and units type of question. Now let's come to the direct answer type of questions, like this. Like this. These are the direct answer type of questions. They are also asked for 1 mark. And these direct type of questions, I will do 2 to 3 questions also, 2 questions maximum. Okay, this type of questions they will also ask sometimes. Okay, so the body is completely submerged in a fluid. The center of gravity G and the center of buoyancy O are known. The body is considered to be in stable equilibrium if they are direct answer type of questions. Okay, so first give me the answer, then I will explain that what they can, how they will twist the question, how they will change the question if this question is repeating. If this question is repeating, how they will twist. First give me the answer. I'm creating the poll, then I will tell you that how they will change the question, how they will twist the question, and how you are going to give the answer. First solve this, then we will discuss quickly. We have done 4 to 5 questions, so I think in the 3 hours we will do 20-30 questions, because in half an hour if we are doing 5 to 6 questions, then 20 to 30 questions we will do in 3 hours. I'm trying to do 10 questions per hour, so I will try, because in 2 marks question I will have more time now. Hello. Okay, so always remember, I'm giving you a very short trick. Whenever you are comparing the stability of the fully submerged body, so always remember, for the fully submerged body, the object should be heavy enough so that they can be stable. Now, how they will be heavy enough? Like if a truck is moving and it is loaded with the very heavy steel, the center of gravity will be lower. So it will be very difficult the truck to be toppled. Yes or no? But if it is filled with the grass, or if it is filled with the husk, so what will happen? The center of gravity will be above and it will be easily toppled. That is why the trucks and the tractors which are having husk or grass, they are generally toppled, and the trucks which are having very heavy steel, they are not toppled. Okay, they may meet the accident due to their momentum, but they will not be toppled. So what happens if you are keeping the center of gravity very low? Then the body is stable. So always remember, for any stable equilibrium, whether the body is fully submerged or the body is partially submerged, the center of gravity should be lower. In fully submerged, the center of gravity should be lower. Center of buoyancy means B. Here the center of buoyancy is told as O, but actually generally we will take center of buoyancy as B. But in partially submerged bodies, like floating bodies, like ships, boats, etc. So for partially submerged bodies, this G is not compared with B, G is compared with metacenter. So if G is below metacenter, M, then again stable equilibrium. And adverse of this is unstable equilibrium. If G is at B or G is at M, then the neutral equilibrium is there. So for a stable equilibrium, you have to just remember one thing, that G should be below. Like in a truck, if a truck is moving, it is having center of gravity lower, it will not be toppled. Similar to that. And also, if somebody is asking the aeroplane is fully submerged or not, so aeroplane is fully submerged in air. Fluid is air. Aeroplane is not partially submerged. Ship is partially submerged. Ship is partially submerged in water. Also, we can say it is partially submerged in air because water is very heavy fluid compared to air, so we generally ignore air. So whenever something is partially submerged in liquid and partially submerged in gas, so we will ignore that gas. We will only say it is partially submerged in some liquid. So ship is partially submerged in water. Aeroplane is fully submerged in air because no fluid, no liquid is there. And submarine is fully submerged in water. Sometimes when submarine comes at the top, it also acts as a floating body. So submarines are designed for the dual nature. Submarines are also designed as a fully submerged bodies. Submarines are also designed as a partially submerged bodies. But mainly their function is to behave as a fully submerged body. Okay, boats are generally the partially submerged bodies. Okay, what is the hot air balloon? Hot air balloon is a fully submerged in air. So you have to understand these things because they may also ask the examples of that. So in this question, what will happen? They are saying the body completely submerged in fluid, center of gravity G, center of buoyancy O. The body is considered to be in a stable equilibrium. So in a stable equilibrium, G should be below. So O does not coincide with the center of mass. This is also correct. O does not correct with the center of mass of the displacement. This is also correct. This is also correct. O should not coincide with. Let's see other options. G coincide with the center of mass of the displaced fluid. No, this is not the concentration here. We are not concerned about G and center of mass. O lies below G. This is also wrong. This is unstable. O lies above G. This is stable. This is also correct. Now here two options are seeming to be correct. Which option we are giving the answer? Which we feel that is more correct? Always remember, in the exam itself they have written, then if you are feeling that more than one options are correct and the question is MCQ not MSQ. If the question is MCQ not MSQ, then consider the most appropriate one. So most appropriate is this, because here they are directly comparing O with G. Here they are comparing O with the center of mass, not with the center of gravity. So here this is correct. This may be correct if all the options are wrong. If they say O lies at G, O lies below G, then this will be correct. If this option was O lies at G, and this was also wrong, then we can give this answer. But this is more correct now. Now we will give D as answer. So here this is correct. I am not saying this is not correct, but relatively D is more correct. Okay, are you getting my point? Because generally if the gravity is evenly distributed now, when the gravity is evenly distributed, generally what we say? Generally we say that center of mass and center of gravity coincides if gravity is evenly distributed. If gravity is not evenly distributed, we cannot say center of mass and center of gravity coincide. So generally we say center of mass, center of gravity are almost the same point. Generally we say, okay. So O we can also compare with center of mass. If fourth option was wrong, then A we have to give answers. Here we are not giving A because this is half correct, half wrong. Okay, half correct, half wrong, because center of mass is given. Na? Okay, so D is more correct, so we are giving D as an answer. Okay, everybody has given the answer D. I know that 100% will be there. But you must know also, if G was written, D was written O lies at G, then A will be correct. Okay, let's move with to one more 1 mark question, that is direct. Okay, now this is the question for the floating bodies. You can see here, one question was from fully submerged bodies and one question is from floating bodies. It was in 2011, it was in 2020. So last 10 to 15 year questions are very important. Always remember. Below 15 years they are also important, but last 15 years first you have to solve. A body floating means partially submerged in liquid is stable at the state if it's. You can say this. To solve these questions, 1 mark question, then we will move towards the 2 marks question also. I will give you some more 1 mark questions that are direct in nature. First, we will do some theoretical question. Always remember the theory part is only in fluid properties chapter and fluid statics chapter. Theory part you will not find any other chapter. 1 or 2 questions will be there for the theoretical part, but otherwise everything is numerical. In every chapter you will find most of the things numerical. Most of the things you will find numerical. 1 or 2 questions may be theoretical, but mostly questions are numerical. Okay, let's do some 1 mark match of the following questions of the dynamics. Here the answer will be meta center lies above center of gravity or center of gravity lies below meta center. Both are correct. So meta center lies above center of gravity or center of gravity lies below meta center. Meta center lies below, wrong. Meta center lies above, correct. Meta center coincide, no, this is neutral equilibrium. Center of gravity is below its center of buoyancy, no. Buoyancy and center of gravity is not compared in the partially submerged bodies. In floating bodies, meta center is compared. So B part is the correct answer. So 93% students have given correct answer. Why you are giving D answer? In floating bodies or partially submerged bodies, buoyancy does not play a role. Meta center plays a role. I have told you in the last class also, in Saturday's class also. Why you guys are doing the wrong things? Okay, we have done a lot of 1 mark questions. Let us do some more 1 mark questions. Okay, let us do some more 1 mark questions. Now let's do this question. This is the match of the following again match of the following. 3-4 questions we will do like this, then we are moving towards your 2 marks question. 3-4 questions we will do like this, then we will move towards the next question. Okay, solve this. I have started the poll. What is pitot tube? What is manometer? What is venturimeter? What is anemometer? What things they measure? They are asking. I have started the poll. You can give me the answer. Just give the option. Just comment the option. The poll will take the answer itself. Just you have to comment the option, which one you feel correct. The poll will take care of your answer. It will automatically grab your option. This question is again 2010, 15 years ago. Guys, just give me 1 minute. I need to send some message for today's class. Just give me a minute. Okay, guys. So let's see. Pitot tube. Pitot tube measures two types of head. One is your total head. It also measures total head. Total head. We can also measure total head if your pitot tube is simple pitot tube, or we can measure the velocity head. Both things. If differential pitot tube is there, we can measure the velocity head. Okay. Using the simple pitot tube, we can also measure the velocity head. How? You can use the simple pitot tube in addition with piezometer. In addition with piezometer, you can measure the total head. Okay. In addition with piezometer, if you are using the pitot tube, I don't know why you guys are giving the sign of laughing. Am I laughable to you? Is something written here, here or here or here? Something written or any mark is there? Am I Teja? Like some cross mark is there? Why you guys, every time when I'm explaining anything, you guys are laughing, giving the laughing sign. Any mark is there? Teja, Teja मैं हूँ, mark इधर है, ऐसा कुछ like this. Everywhere the disturbing element is there. Everywhere the disturbing element is there. So whatever the disturbing element or whatever the elements trying to frustrate any student or any teacher, I will tell you, there is in every cleaned city there is also one gutter. In every cleaned city there is also one gutter that is below the street level. So every city, when you are observing it, is very clean. There is also one gutter. So in that gutter, these all the disturbing things will be generally are flushed in that gutter. Okay. So I will be very happy to say this, that whatever are the very dirty things na, they are flushed in that. So always flush your whatever the bad things or bad what I will say, whatever the bad things or bad actions you have now, always flush those in the gutter. Always flush these things in the gutter. Otherwise, what will happen, if somebody will, if you will be grabbed by someone, or if you will be grabbed by police or anything doing this na, then they will do this thing to you. So before doing this thing to you, if you are doing it with your qualities na, flush these bad qualities to gutter by yourself. Otherwise, if somebody will grab you na, they will do the same with you, not with your quality, because nobody will remove your qualities. Everybody will remove you from the society. So they will put you behind the bars, or they will do these type of things, because these things will be staggered, and someday you will be becoming the bad citizens. Okay. Are you getting my point? So always remember. And whenever I find those peoples na, I generally report them. Always I report them. Whenever I'm finding someone doing pollution on the roads, I report them. I always report them. So I'm not the person that who will ignore these things. I am not that type of person. I'm not that type of citizen who ignores generally the bad elements of the society, or I'm not that type of teacher who ignored the bad things in my class. Whatever the means I found, I use, or I choose to find those peoples, I generally find those people. Sometimes I have grabbed also those students who are doing these things, and then they say, sorry sir, we are the students, please forgive us. And I feel very pity, but I'm not that type of teacher that I will ignore. I have done this thing in the past also. I have searched those students who are disturbing others, and I have done the complaints, and I have done a lot of complaints on that. And they generally say, sorry sir, sorry sir. Sometimes their parents also came, because I had one offline center. So I always do the right justice with those who are disturbing others, who are disturbing the teachers. So please refrain. Otherwise, if I will grab someone in, sometimes I also grabbed someone in telegrams. I have done a lot of things. So if it feels intimidating to you, so please correct yourself. Don't disturb others, because a lot of bright students are here. Okay, a lot of bright students are here who are who want to secure their future, and I will not spare the future of those for you. And I will grab you, because you guys are doing in every class, I know. So I will grab you, I will report, because I'm a responsible citizen. I always do that thing. So if somebody is saying, "Na sir, please start, sir, please ignore these things," I never ignore. Okay, I never ignore. Anupama, please understand, if you are a good citizen, na, you don't ignore these things. So you are also in going in the same path if you're ignoring these things. I never ignore. I never tell anyone to ignore. If somebody is poking any teacher, it is your responsibility. Do not let him poke. Do the right treatment. I always believe in treatment. I'm follower of Bhagat Singh. I'm not follower of any other those persons who will show you if you are hitting and he will show you again, hit me again. I'm not that type of person. And I always ask the students, don't be that type of person. I always have revolutionary thoughts. I doesn't matter if 1 or 2 minutes are wasting. But I always want to treat them because they are doing everywhere this thing. Okay. So don't tell me to ignore. I will never ignore. There are a lot of students they ignore. A lot of teachers also they ignore. I never ignore. Somebody is beating someone on the road. You are ignoring. Very good. Somebody is doing wrong deeds. You are ignoring. Then people say that why the citizens are not responsible. So if somebody is saying ignore, na, you are on the same path. Okay, let's come to the class. I will give 2 to 3 minutes for those things. Manometer. What is the manometer? Manometer is generally used. If you are thinking that 2 to 3 minutes are wasting, then you are also wasting your time in understanding the things. I will just give the answer and I will move ahead. Manometer. Manometer is used for a lot of things. It is also used to measure the pressure of a liquid. It is also used to measure the pressure of a gas. It is also used to measure the pressure difference between two liquids or two gases. So it is used in common sense, if you will say, it is used to measure the pressure or pressure difference. Pressure or pressure difference. Pressure or pressure difference. Next, venturimeter. Venturimeter is only used to measure one thing, that is discharge. I'm not concerned about which is matching with. I'm just writing what my knowledge is there. So what happens if they are not giving this option, they are giving different options, then you can also match. Always try to add your knowledge here. Always try to add the content here. What is anemometer? Anemometer is of two types. One is hot wire anemometer. One is hot wire anemometer. I don't know you have studied this thing in hydrology or not. This is the part of the hydrology. And one is the cup anemometer. I have given one question also in the cup anemometer, cup type. I have given one question of the cup type in drag and lift chapter. I have given one question. This is cup type. Okay, in today's class at 7 p.m. we will also do these things. So these two, both are measuring what? Both are measuring your wind velocity. Wind velocity. Okay, now we can measure. We can connect this with 1, 2, 3, 4. So pitot tube will be measuring the velocity of flow in a pipe or total head. So velocity is there, so we will give the velocity as answer. So this is A, 2. Then manometer will be measuring the pressure in the pipe, 1. Venturimeter will measure the discharge in the pipe, 4. And the remaining is 3. Air and gas velocities or wind velocities, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3. It is given in C part. C part is the correct answer. Okay, 100%. The answer will be 100%. I'm not concerned about the option or answer. I'm concerned about only the explanation. Okay, this thing you have done in the class itself. So this thing I'm removing. Okay, numericals we are not going to do right now. We are going some more theory questions now. For next 10 minutes we are going to do more theory questions. Then again I will do to the. Okay, this is a very good question. This is a very good question because it is a combination of FM and hydrology. This is again match the following, but this is a very good question. This has been asked, I think, in GATE 2014. Yes, 14. Yes, 14 is there for 1 mark. Here anemometer is also asked, wind velocity. Hygrometer is also asked. It is also the concept of the hydrology. Pitot tube is again fluid mechanics. Tensiometer is again hydrology or irrigation, you can say. So it is a combination of hydrology, irrigation and fluid mechanics, everything. So if you know the hygrometer, okay, If you know the tensiometer, then you can easily give the answer. Okay, let's start. You know what is lysimeter, what is tensiometer, what is hygrometer? I think these things have been taught to you in the hydrology. I will tell you in a very short way. I will tell you. First, give me the answer, then I will tell you this thing. Only comment whatever A, B, C, D you are getting. Then I will tell you in short what is hygrometer, how you are measuring the things with the hygrometer. Okay guys, let's see. Anemometer I have told you for one velocity. Now how to use the hygrometer and why hygrometer is used. How to use the hygrometer and why hygrometer is used. In the last class, in the theory class, I have told you the vapor pressure of liquid at different temperatures. The vapor pressure of liquid at different temperatures I have told you. Now how to calculate the vapor pressure of liquid. For calculating the vapor pressure of liquid, we have to calculate the pressure of the surface molecules of the liquid. But we don't have the device yet which will calculate the pressure of the surface molecules of the liquid. We don't have any device like that. So how we can calculate the vapor pressure of liquid? We have one device that can calculate the vapor pressure of air. So what we do, we calculate the vapor pressure of air, EA. Okay, at any temperature we calculate the vapor pressure of air. Okay, we don't know the vapor pressure of liquid, EW. We calculate the vapor pressure of air. What happens? This is a liquid. Now what will happen if EA is more and EW is lesser? This EW is lesser and EA from the top is more. Then the evaporation will not happen. We try to reduce that EA. We try to, suppose the temperature is T is equal to 20 degrees centigrade. Okay, we will reduce that air. This EA is suppose 101 kilopascal. We are reducing that. And that EA is continuously calculated using this water vapor content of air, using this hygrometer. Water vapor content of air is measured using this hygrometer. Continuously we are measuring. Now at any pressure when the EA value is 2.34, at EA value when it is 2.34, we have seen that the evaporation has started. So how the evaporation has started? Because EW have become equal to EA when the EA value is 2.34 at any given temperature. So this is the point of saturation. Saturation means EW has become equal to EA. Now the evaporation will start. So at this saturation point, whatever is the vapor pressure of air, that is also equal to EW. That is why EW is sometimes also called saturation vapor pressure of air. So what happens when this EW becomes equal to EA at 2.34, at T is equal to 20 degrees centigrade, when the atmospheric air pressure is 2.34, when we are reducing the air, in a container we are reducing the pressure of air. So what happens? This liquid starts evaporating, means at this pressure there comes the saturation, means at this pressure, at this air pressure, at this EA, it has become equal to the vapor pressure of liquid. So that is why EW is sometimes also called the vapor pressure of air at saturation or saturation vapor pressure of air, because if it is equal to EA, EW is equal to EA, so EA is that pressure where the evaporation is happening. So that is why EW is also calculated using this. We are not directly calculating EW. We are reducing the pressure of the air at the time when the evaporation is starting. We are calculating EA. At this time, it is also equal to EW. So we'll write down EW as vapor pressure of liquid. It is calculated. How it is calculated? Calculating the vapor pressure of air at saturation. So that is why EW is also known as the saturation vapor pressure of air. So EW is the air pressure where the evaporation starts. Simple definition of the saturation vapor pressure of air. This is also equal to the vapor pressure of liquid. So EW is also sometimes called as saturation vapor pressure of air, because in hydrology you will not see any vapor pressure of liquid term thing. You will see saturation vapor pressure of air. That is also vapor pressure of liquid. Okay, saturation vapor pressure of air means it is that air pressure where the evaporation starts, means where it becomes equal to the vapor pressure of liquid. Saturation vapor pressure of air is also vapor pressure of liquid. Okay, so how we will measure? When we will measure the vapor content of air. Vapor content of air is also used to predict whether the rainfall will occur or not. So all this thing is used using hygrometer. Hygrometer actually measures the vapor content. When the vapor content of air, of atmosphere becomes nearly 100%, then the precipitation starts. Okay, so when the precipitation will start, when the precipitation will not happen, what is the prediction? This weather department do the prediction using this vapor content of air. In IIT Roorkee also there is a center that is called Center of Hydrology, Department of Hydrology. There also they have installed this hygrometer. It generally displays the vapor content of air. If it is above 90%, there are more chances of precipitation. Okay, so this measures vapor content used for the forecasting of the precipitation. Okay, also for vapor pressure of liquid. Pitot tube we know, velocity head and total head. Generally, if one answer we have to give answer by velocity head. If one answer we have to give, we will give velocity head, because total head can be measured by anything. Pitot tube generally measures velocity. So if one answer we have to give velocity head. If total is also there, total head we can also give the answer. And tensiometer is used to measure the capillary potential of soil. Whatever the water is stored in the soil, in the capillaries of soil. So it is generally measured to calculate the capillary potential. Generally it is done for calculating evapotranspiration, capillary potential. For evapotranspiration calculations, this tensiometer is used. A device called lysimeter, and lysimeter device we generally install tensiometer to calculate the depletion in capillary water. Because when we'll calculate a depletion in capillary water, then we can get the evapotranspiration value. So wind velocity is given in where? 4. Vapor content is given where? 3. So 4, 3. Then velocity head is given where? 2 and 1. Just reverse. Just reverse, no? 4, 3, 2, 1. Yes. So it is given in D part. 4, 3, 2, 1 is given in D part. So D is the correct answer. So again, I'm saying I'm not concerned about the answer. I'm concerned about the content or the knowledge you are getting. Again, next question. This is a very good question. For a steady incompressible flow, laminar flow between two infinite parallel stationary plates, the length of the plates is infinite, only the width is defined. Okay, the shear stress variation is for steady incompressible laminar flow. The shear stress variation is. Quickly give me the answer. For parallel plates, it is not asking for the pipe, it is asking for the parallel plates. Whether it is quadratic, whether it is linear, and what is the shear stress at the center? What is the shear stress at the center? So here the answer will be B part, because shear stress variation is linear and zero shear stress at center. Linear like this. This is tau wall. Tau wall is maximum. Tau wall is maximum. These are the two plates. And the flow is happening here like this. Okay. So B part is correct. I think this is clear. But the velocity variation is parabolic. If you will see the velocity variation, it is parabolic. It is U max here. When both plates are stationary, both plates should be stationary for U max. This is velocity distribution. The velocity is quadratic and the maximum velocity is at the center. And shear stress is linear and shear stress is maximum at the wall, zero at the center. So B part is the correct answer. Okay, let's move to the next question. Now let us do 1 or 2 questions more for 1 mark, then we will be moving towards the 2 marks questions only. Okay, please solve this question. This is a very good question. This question is of pipe flow. A steady incompressible flow. Steady means nothing will change with time. Incompressible means density is constant. At 2 sections, density will be same. Flow through a closed conduit of uniform cross section means a closed pipe of uniform cross section. The direction of flow will always be. Very good question. This is of 1 mark. Direct question of 1 mark. You can give the answer. I'm creating the poll, then you can give the answer. Till then, I'm searching the next 1 mark question for you. What happened? I have to again come back. Okay, this was the question. Now here you have done wrong. The answer is not B. The answer is D here. Higher to lower piezometric head. How? Let us see. Only 5% of students have given the correct answer. Always remember, when the pipe is horizontal, then datum head at both points are same. Okay, datum head is same. This 1 to 2, the datum head is same. Okay, and if the pipe is of constant cross section, it is given the uniform cross section. So here velocity will be same. Here the velocity will also be same. Why? Because constant cross section means discharge is coming Q. Constant cross section means velocity will not change. Cross section is not changing, and conduit is closed. Conduit is closed. So cross section will not change means velocity will not change. So velocity head is same. Pressure head is same. So if you will write down the equation between 1 and 2. So P1 by gamma plus V square by 2G plus Z is equal to P2 by gamma plus V square by 2G plus Z plus head loss. And always remember, the flow happens in the direction of head loss. Where the head loss is positive, na, in that direction the flow happens. Okay, so head loss will be equal to how much? Head loss will be equal to how much? This Z will cancel out because datum is same. This is horizontal pipe, okay? But here horizontal pipe is not written. Nowhere it is written that the pipe is horizontal. So here HL will be equal to how much? P1 minus P2 by gamma. So when this will come positive, when this head loss will come positive, when P1 is more than P2. So from a higher pressure, P1 is more than P2. So from 1 to 2, the flow will always happen when the P1 is greater than P2. Then the flow will happen from 1 to 2 in this direction. If P1 is less than P2 now, so flow will happen from 2 to 1. But in horizontal pipe. But if the pipe is inclined, for inclined pipes, the Z will not cancel. For inclined pipes, the Z will not cancel. So inclined pipes, HL will be equal to P1 by gamma, V square by 2G will cancel out, plus Z1 minus P2 by gamma plus Z2. And if this is coming out to be positive, the flow will happen from 1 to 2. So when it will be positive? When the piezometric head at 1, this is piezometric head, at 1 is more than the piezometric head 2. Okay, then only this will happen for inclined pipes. So if here it is not written the pipe is your horizontal. Nowhere it is written. If it was written horizontal pipe, then we can give the answer that from higher pressure to lower pressure. Because if the pipe is inclined, suppose pipe is vertical, inclined pipes are vertical. In vertical pipes, we will check with the piezometric head. Okay, and if the cross section is not constant, we will check with the total head. Okay, how we will do in the exam? I don't know how you would do in the exam. This is very difficult. This is very difficult. This is very difficult to see if horizontal is given or not. Very difficult. If horizontal is not given here, we are not able to see that horizontal is not given. Very difficult to see. No, it is very difficult. How you are here horizontal is not written. Here horizontal is not written. It is very difficult to see. You're getting my point. Whether inclined or horizontal. If it is not given, the pipe is inclined or horizontal. If it is not given pipe is inclined or horizontal, you will take all the options, na? You will take all the options. So here horizontal is not given, so I have taken both the options, na? Here I can write down the same thing. If the pipe is horizontal, then also I can write down the same thing. P1 by gamma plus Z minus P2 by gamma plus Z. Here also it is the difference between the piezometric head. If it is not given horizontal, we will take all the cases. So in all the cases, if the pipe is not given horizontal, we will always say this equation will also be applicable in horizontal pipes. No? Okay. If I will write down all pipes. Okay. You guys are literally, sometimes I feel you guys are literally studying in class 1 or 2. All pipes. P1 by gamma plus Z1 plus V1 by square by 2G is equal to P2 by gamma plus Z2 plus V2 square by 2G plus HL. Okay, one condition is given. What is given? Uniform cross section means V1 is equal to V2. So this V1 and V2 thing will cancel out. When it will cancel out, the Z1 and Z2 are remaining. It is not given that Z1 and Z2 are equal. That is where we are not cancelling out. If I will tell you any additional thing, now you guys are getting confused. I have told you the thing for the horizontal pipes. Why you are getting confused? I have told you this thing here. Because you always consider the pipe horizontal. Here horizontal is not given. That is why we don't have to consider the horizontal condition. That I was telling you. And whenever I am adding anything additional, you guys are getting confused. I was telling you that you are only considering the horizontal thing. That is why you are getting confused. When it is not given horizontal, you don't have to only consider the horizontal option. That thing I was trying to explain you. We will take for this now, for any type of flow, not pipe, for all flows. For all flows this happen. All real flows. All real flows. All real flows. This thing will happen. If the flow is ideal, HL will be 0. For all real flows, this will happen. So if the cross section is uniform, then only the velocity will be equal, because discharge is coming and outgoing same discharge. Area is also same, so V1 will be equal to V2. V1 will be cancelling out. So head loss will be equal to this. And if this value is more and this value is less, then the flow will happen from 1 to 2. If this is more, this is less, so 2 to 1. Flow will happen in that direction where the head loss is positive. If flow want to happen from 1 to 2, this head loss will be like this. So if the velocity is constant, then it will flow from higher piezometric head to lower piezometric head. And always remember, if it is not written that the flow is of uniform cross section, if this is also not written, then you will say from higher total head to lower total head. If this is also not given, if this is not given that the cross section is uniform, then the answer is from higher total head to lower total head. Getting my point? Because the head loss is always this. This is the head loss. Always. In the last class, I have given this formula to you. For the real flows, head loss is always this. But if V1 is equal to V2, then V1 will be cancelling out. So for all flows, the flow happens from higher total head to lower total head. If the cross section is uniform, then from higher piezometric head to lower piezometric head. If the pipe is also horizontal, then ZZ will also cancel out. Then it will flow from higher pressure to lower pressure. Got it? Nitish Kumar, tell me. If one more condition is given, then we will say from higher pressure to lower pressure. Are you getting this point? Then Z will cancel out. Because here one more condition of horizontal is not given. So we will only take those conditions which are given. Are you getting my point? Tell me. Okay, so anything which is not given, we will not consider that thing by saying Om Phat Swaha, horizontal is also there. Not given, na? How we can say Om Phat Swaha? Okay, I was saying that this thing you are considering, that is why you are doing the mistake. You have to consider this, whatever is given you have to consider. So D part is the correct answer. And why I have given more time here? Because 95% students were wrong here. That is why I have given you a lot of time. Anybody is having any more doubt in this? Because I have waited for your understanding. Because this question, if this question will come again and they have not given uniform cross section, then you will do again the mistake. If uniform cross section is not given, so you will give the answer from higher total head to lower total head. If only given for a steady incompressible flow, flow will happen from higher total head to lower total head. Steady incompressible flow of uniform cross section, higher piezometric head to lower piezometric head. Steady incompressible flow with uniform cross section and horizontal pipe from higher pressure to lower pressure. Okay. Okay, so we have reached towards the pipe flow chapter. Now let us do one question of your next chapters, like dimension analysis and model similitude and impact of jet, like these things. Okay, let us do one more question. Okay, this question. This was a very interesting question here. But here pole is not given, so I'm writing down the options here above because I don't have a space at the bottom. I'm writing down ABCD here. So A is your 3241, 3241, 3241, 3241. C is your 2341, 2341. D is your 1324, 1324. Let me also check what is the correct one. Okay, this is 24. Okay, now I'm creating the poll. In the previous poll, I have given the answer. Now let us start a new poll. Okay, I have started the poll, give me the answer. I have started the poll, give me the answer. So Mach number, I have told you that it is the ratio of inertia force to compressibility force. So it is given in 2. Velocity of sound, ratio of fluid velocity to velocity of sound, V by C. So it is 2. Reynolds number, I have given you ratio of inertia force to viscous force because viscous force is dominant. So it is given in 3. Then Weber number is the ratio of inertia force to surface tension. It is 4. And Froudy's number is the ratio of inertia force to gravity force. It is 1. So 2, 3, 4, 1. It is given in C part. This is the correct answer of this question. C part. Okay. So these numbers will be asked a lot of times. Okay, now let's do some 2 mark questions. Okay, this is a very good question. Let us start from the fluid statics, because in properties you will not find any question of 2 marks. Generally you will find you can find some question, but generally the important questions you will find in the fluid statics for 2 marks. For 2 marks, the important questions you will find in fluid statics. So this is your next question. I think we have done 11-12 questions. 11-12 questions we have done. So now we are going to do again 12-13 questions from the from 2 marks. So the figure shows a U-tube having 5:5 meter square cross section. So this is not a tube of circular cross section. This is a square cross section filled with mercury, specific gravity 13.6. Here mercury is there. Now up to a height of 20 centimeter. Okay, this is 20 centimeter. In each limb open to atmosphere, 5 centimeter cube of water is added to the right limb. Here right we are adding the water. So whenever we are adding the water now, due to the pressure, this mercury will go down, this mercury will go up, but the level will not be the same. Why? Because if the fluid at both sides are same, then the level will be same. Here water is there, it is light. Here mercury is there, it is heavy. So here it will be down, it will go up, but the level will not be same. So here if we are adding 5 meter cube, 5 centimeter cube of water, suppose this is the H amount of water we have filled. So what will happen? This water will try to push mercury down. This water will try to push mercury down. So this much amount of mercury will be down. Okay, this much amount of mercury will be down. And here the mercury will be up also. Whatever the amount down here, the same amount it will go up. This much amount, the mercury will go up also. Let us consider this as Y. Let us also this is considered as Y. And the total height of water will be how much? Total height of water from here to here. Whatever is the height of water, that we will consider as H. We'll consider this height as H. How we will calculate this? This height H will be volume of water 5 centimeter cube divided by area of the tube. Volume of the water, whatever we have filled, divided by the area of the tube. So from that, what we have to consider? We have to consider the new height of mercury in the left limb. So in left limb, the new height will be equal to 20 centimeter plus Y. 20 plus Y will be the new height. The new height in centimeters you have to give the answer. Okay. So give the answer. I think you have to give the answer 1 digit after decimal. Okay. 1 digit after decimal. The answer will be in 2 digits, but give me the answer 1 digit after decimal. Because you have to approximate now. So do the approximation and give the answer 1 digit after decimal. 1 digit after decimal. So I'm creating the poll and giving you 90 seconds because this is 2 marks question. No? For 2 marks question, I have to give more time. I've explained this thing, now you can calculate. Give the answer in the comment box. You have to just type the answer 1 digit after decimal in centimeters. Okay guys, let us see what we have to solve. So first of all, you must understand that the initial height was 20 centimeters. So here also this is 20. Here also again this is 20. Now, due to the pressure of water, this has come 20 y centimeter down. So we will write down this as y because this level of the mercury is same. So this is also y. Because mercury has come down also here y. Here it has gone one up y. So this is also y. So let us solve this by applying simple concept. Here the atmospheric pressure is P atm. P atm we can generally call it as P atm, or in gauge we can call it as 0 also. So P atm we will taking directly, plus how much we are going down, H. H we are going down, but in water, so it will be gamma W into H. Now from here we are going down in mercury, again coming up in mercury. So the pressure will not change. Directly we will come here. Okay, pressure will not change. Now here we are going 2y up, and 2y up in which? In mercury we are going, because this is also mercury. This whole thing is mercury. So 2y we are going up, so the pressure will be gamma of mercury, that is 13.6 times heavier than water. So 13.6 gamma W into height is 2y. That is equal to how much? P atm again. We have again reached to atmosphere. So here P atm will cancel out. So whether we will take atmospheric pressure 0 in gauge, we will calculate in gauge, or we will calculate in absolute, the answer will be sim. So now here we will write down y as how much? Y as gamma W into H. So H upon 13.6 into 2. So that will be 27.2. Okay, now what is H? You can see here H is how much? Total volume of water divided by area of tube. Now volume of water is 5 centimeter cube, and area of tube is 5 mm by 5 mm square cross section. So 0.5 centimeter into 0.5 centimeter. 5 mm means 0.5 centimeter square. So it will be 5 upon 0.25. 5 upon 0.25 means 20 centimeter. So H will be equal to 20 centimeter. So it will be 20 upon 27.2. So I think we will get this thing as, let us check. .735. 0.735 I forgot. Okay, so 0.735. So the new height, this is in centimeter. The new height will be 20 was already there. So from 20 it is how much it is raised? It is y rise. So 20.735. So we will give 20.7 as answer, because one digit I have asked. So we will give 20.7 as answer. 20.7 will be the answer. So within time nobody has given the answer. Within 90 seconds nobody has given the answer. So no issue. Let's move to 2 marks question. Always remember, you should have only 1.5 to 2 minutes. So you should have that speed. If you are not having that speed, because after explaining the questions, after explaining everything, I have given you 1.5 minutes. You don't have 1.5 minutes after understanding the question. You have total 2 minutes for understanding the question, for getting the concept, for making the diagrams, and then solving. So for solution only, you have only 1.5 minutes. Please understand that. If you are not getting the solution in this time, it will be very difficult. Now let us do one more question, that is again of 2 marks. Then we will move towards some question of kinematics and dynamics. There is a fluid that is gas here, and it is connected to vacuum pump. Vacuum pump means it is actually vacuum pressure here. The negative gauge pressure is here. Then it is connected to one fluid 1. Then it is connected to another fluid 2. Then it is connected to another fluid, that is water. This is the water. And here the pressure here here. The pressure is P atm, but P atm pressure is where? Above the surface of water. At the surface of water, the pressure is P atm. Here, the same pressure will not be there. Here, the pressure will not be P atm. Why? Because this fluid and this fluid is not same. You cannot say at this level the pressure will be same. No, because below this the fluid is different, and above this the fluid is different. Are you getting my point? Okay. I think this is you are getting. But here we can say the pressure is same. Where? At this point. At this point here we can say the pressure is same, because below this the fluid is only water. At this level we can say the pressure is same. Okay. At this level, here or here or here or here, the pressure is same. So at this level we cannot make the P atm pressure, because outside the pressure is P atm, but here it will not be P atm because the fluids are different. Okay, so I have given you the hint. Now what is it is asking? It is asking the gauge pressure in kilonewton square. No, kilonewton per meter square. The gauge pressure in kilonewton per meter square should be there. It should be in kilonewton per meter square. Kilonewton per meter square. Up to 2 decimal places is. So you do not have to give answer in 2 decimal places. You have to give answer only in 1 decimal place. Because I know now in 2 decimal places a lot of students will do the mistakes. Just give the answer in 1 decimal places only. 1 decimal place only. P1. This P1 pressure is it is vacuum pressure. So give the answer in gauge. It is vacuum pressure now, so give the answer in gauge, and don't add minus, only give the answer magnitude only. Okay, not, or don't include minus, because I don't know, whether it will take in the negative sign or not. But in GATE exam you can give the answer in minus. If it is coming out to be in minus, you can give in minus. If it is coming out to be in plus, you have to give the answer in plus. Okay, in GATE you can give, but here don't give in negative sign, give in only positive sign, whether it is coming out to be negative or positive. Okay, so let us create the poll. 120 seconds I am giving you time, integer type. Now I am giving you 2 minutes. Please solve this. One person has come, he is saying good luck for you guys. I think you should say good luck to you guys. Okay, that is also fine. And why I am correcting your English? Why I am correcting your English? I don't need to correct the English, because I am correcting your English because these guys are the GATE aspirants, and there is also one subject that is English in GATE. In aptitude, GATE is also asking English. They will simply ask one question, good luck, fill in the blank, you. To, for, on, at, and you have to give the exact preposition. So I think, as per my knowledge of English, even I don't know a lot of English, but as per my knowledge, the preposition should be to. Good luck to you. Good luck for you is not correct. Okay, so one person has come, he has got some learning here in this class. So in GATE exam, you will also have English. So please don't forget to learn English. English is also very essential. 2 to 3 marks they will generally ask the question from in the aptitude section. I'm not that much good in English. I'm not that much good in English, so you can also check this in Google also. So the best possible thing is to say good luck to you. Okay, now the students are also solving this question. Let us do this question again. Let us solve this question again. So here at this level, we are not going to do anything. At this level, we are not going to equate any pressure. We are going to equate the pressure at this level. At this level, here the pressure will be same everywhere. So here the pressure we will calculate and we will equate at both sides. So here from the PATM side, the pressure is PATM. At the PATM side, atmospheric pressure is given or not? Atmospheric pressure is given here, 95.43. You can see here, 95.43 is given here. So PATM plus how much? Gamma W, gamma of water, into this height is given as 0.5 into 0.5 is equal to P1 plus what is the height here? 1.5 minus 1. I think this is also 0.5. This is also 0.5. Everything is 0.5. Okay, no issue. So this is specific gravity 0.88. So 0.88 gamma W into 0.5. Again plus specific gravity 0.95. So 0.95 into gamma W, again 0.5. So we have equated this. So now let us get the value of P. So P1 will be equal to PATM minus will be there or plus will be there? Minus will be there or plus will be there? Let us check. It will be minus because 0.8 plus 0.95. .83, so 0.83. 0.83 gamma W is how much? 9.81 into 0.5. So it will be PATM minus 4.07. 4.07. Okay. It is coming out to be 4.07, na? Am I doing it correctly, na? Am I doing it correctly? Yes or no? Tell me. If not doing correctly, you can tell me. Yes, 4.07. 0.88 hai. Yes, I have taken 0.88. I have taken 0.88. 0.88, 0.95. 0.95 plus 0.88. 1.83, and this gamma W will be minus. So 0.83 will be there. That is correct. Don't find anything wrong. I don't find anything wrong. I don't find anything wrong. Yes, 4.07. Okay, now this is the absolute pressure of thing, but it is asking the gauge pressure. Please understand the gauge pressure it is asking. What is gauge? P gauge, P1 gauge. P1 gauge is actually P1 absolute minus PATM. So P1 absolute, we have got this. If we will minus the PATM here, so it will be minus 4.07 kilonewton per meter square. Why kilonewton per meter square? Because gamma W we have kept in kilonewton per meter cube. Gamma W we have kept in kilonewton per meter cube. So it will be in kilonewton per meter square. So the correct answer will be 0.95 into 1. Here 0.95 into 1. Why 0.95 into 1? Okay, here, okay, correct. 0.95 into gamma W into this height, okay, 1, okay. Now it is correct. So let us again check. (0.89) is there, okay? Now it is correct. Now it is correct. 8.73. 8.731. Okay. So 8.7 V1. Now correct. Because this height 0.95 is having height 1 meter. Okay. Now that's correct. Okay, got it. So 8.731. So we will give the answer as 8.7 because I have asked in one decimal place, but it is negative. In GATE you will give the answer negative. Here I don't have any option of negative. You can see that is why I have said don't include negative sign. But in GATE, if the same question is asked, you have to first apply the negative sign. First click on the negative sign. Then you have to first click on the negative sign. Here negative sign is not there, but in GATE exam, because some of the students have never taken GATE before, so I am telling you there is also one option to put negative sign first. So first put the negative sign, minus sign, then write down 8.73, whatever they are asking. 2 digits they are asking, so put down 8.73. 1 digit they are asking, so 8.7. If integer they are asking, nearest integer, so -9. -9 is the integer. So first put negative sign in the GATE exam. Here I have not asked because we don't have any option of negative first. So 8.73. No, 8.7 because I have asked in one decimal place. No? So 8.7 I will only give. Okay. 40% students have given correct answer. This is the leaderboard. Nagraj, Manoj, Vinay, top 3, then Ritika, then Yusuf, then Swagatam, and overall, how many students are giving answer? 46. Very good. Today the strength is very good. Presently, I don't know how many students are live, but the strength is very good. Up to now, till now. Okay, let's do one more question of kinematics and dynamics also. Let us do some questions of kinematics of dynamics also. Okay, I'm not giving you that Venturi type meter type of questions because they are lengthy, not conceptual. Venturi meter questions are only lengthy, they are not conceptual. Okay, so let us do one more question. Please read this question. This is of GATE 2010 2 marks. I will be solving this question for you, but after your answer. Okay, so ABCD you have to give answer, and I'm creating the poll. 150 seconds I'm giving the time because you have to also read out this question. So 150 seconds I'm giving for this. So read this question and give me the answer. I think this will be your 14th or 15th question. So 5 to 10 questions we will do more. 5-10 questions we are going to do more. Solve this quickly. In the evening at 7 p.m. you can also come. We will do again 20 to 25, 20 to 30 questions, near between more than 20 and lesser than 30. Near about 25 questions we will do in the evening class also. So total around 50 questions or 40 to 50 questions, any range of 40 to 50 questions we are going to do, combining both the sessions. That will be more than enough for us. Okay, guys, I think you guys have given the answer B as 1.5 rho V square. So point 1 and point 2 in a pipeline are having velocity V and 2V. Now, whether the flow is happening from 1 to 2 or 2 to 1, we don't know. For that, we must know the total head between at 1 and 2. So both the points, now you were saying, sir, from 1 to 2, the velocity is increasing. So the flow should also happen from 1 to 2. No. The flow may also happen from 2 to 1, where the velocity is decreasing from 2V to V. Okay. So please understand, always the flow will not happen 1 to 2. This will depend upon the total head. Okay. Both the points are at the same elevation. Same elevation means the horizontal pipe is there. Okay. So only the pressure head and velocity head combination of that matters. The fluid density is rho. Okay. The flow can be assumed to be incompressible. So rho is also constant. Inviscid is steady and irrotational. The difference in the pressure P1 and P2 at the points 1 and 2 are. So the pressure at point 1 and 2 will be how much? Just we have to put the Bernoulli equation. So P1 by gamma, assuming that flow is happening from 1 to 2, P1 by gamma plus V1 square by 2G plus Z is equal to P2 by gamma plus V2 square by 2G plus Z plus head loss. Okay. Now it is written that the flow is inviscid. Generally the flow, this head loss happens due to the viscosity, but it is also written as inviscid. So when the flow is inviscid, this head loss will be 0, because the flow is inviscid. Okay, for inviscid condition, inviscid is given, then they are hinting for making this HL is equal to 0. So P1 by gamma minus P2 by gamma. So P1 minus P2 by gamma. P1 minus P2 is asked. So P1 minus P2 by gamma. That will be equal to how much? Z will cancel out. V2 square minus V1 square. So V2 is 2V. So 2V square minus V square divided by 2G. Gamma will write down as rho G, because gamma is unit weight. So Gg will cancel out. Okay, this will be 3V square minus V square. Sorry, 4V square minus V square is 3V square. 3V square by 2 is equal to 1.5V square. So P1 minus P2 will be 1.5 rho V square. And this thing is positive because density is positive, V square is square, so square is also positive. So means this is correct that the flow is happening from 1 to 2. This is correct that the flow is happening from 1 to 2, because this P1 minus P2 is positive. P1 is more, P2 is lesser. But always remember that the head loss is 0. So we have to check more conditions for the flow direction. We have to consider the more condition for the flow directions, because head loss is 0 here. Okay, let's move to the next question. B is correct. So more condition need to be checked, because head loss is 0 here. It is ideal condition. So we cannot always say 1 to 2. Some more conditions are there. Okay, next thing we are going to do some 2 marks question from the let us do some more question from next chapters. Let us do this question. This is a very good question from the Darcy-Weisbach equation. This is one very good question from the Darcy-Weisbach. Let us do this question. Oh, so here please understand, this is d1, not d raised to power 1. This is d2. This is not d square. This is d2 actually. This is d1 and this is d2. So an incompressible fluid is flowing at a steady rate in a horizontal pipe from a section. The pipe divides into 2 horizontal parallel pipes. So there are two pipes divided, okay, diameter d1 and d2. So this is d1, d2, and d1 is 4 times d2. d1 is larger, d2 is smaller. So d1 is 4 times d2 that run a distance of L each and then again join back to a pipe of original size. Both of the parallel pipes assume the head loss to be friction only and the Darcy-Weisbach friction factor to be the same. The velocity ratio between the bigger and the smaller branch pipes. So head loss will be same because they are having the same distance covered, same length covered. So head loss will be same. When we are creating the head loss same, we will get the what we will get? We will get the velocity ratio. This is a very simple question, but again it is asked for 2 marks. So you have to give the answer 1 digit after decimal. 1 digit after decimal. If it is coming out to be integer, you can give the answer integer. Otherwise, 1 digit after decimal. 1 digit after decimal. Okay. 1 digit after decimal. So I am creating the integer type poll. 150 seconds I am giving you because this is a lengthy question. This is a lengthy question. Okay. One student is saying 2. Okay, let's see. One student is saying 0.5. Let's see. Between the bigger and the smaller branch pipe means velocity in the bigger pipe, this pipe. Bigger is one pipe. Pipe 1 is having more dia. So velocity in one pipe, V1 divided by velocity in smaller pipe 2. This is asking. This they are asking. V1 by V2 they are asking. Bigger to smaller. 1 is bigger, 2 is smaller. This they are asking how much. So when we will put the head loss same, so HF1 is equal to HF2. So FL V1 square upon twice the D1 is equal to FL V2 square upon twice the D2. So length is same, friction factor is same, FL will cancel out, 2G will cancel out. So V1 by V2 will be equal to root D2 by D1. Sorry, root D1 by D2. So D1 is 4 D2, so it will be under root 4. The answer will be 2. 2 is the correct answer. Okay, all of the students have given the correct answer. Okay, let's move towards the next question. Okay, this is a very good question that may be asked. This is of 1 mark, but this may be asked. This is a good question. This may be asked. The ratio of momentum correction factor to the energy correction factor. Energy correction factor means kinetic energy correction factor for the laminar flow in pipe. For laminar flow in pipe, the ratio of momentum correction factor and the energy correction factor they are asking. 1 by 2, 3 by 2, 2 by 3, 1. So I'm giving you only 60 seconds because this is of 1 mark question. This you can also do. Always remember, if you know one thing now, if you know one thing, then you can always correct this question. If you know one thing between alpha and beta, you can always do this question. Alpha is always greater than beta or equal to beta and greater than or equal to 1. Both are greater than or equal to 1 and alpha is generally greater than beta. Only for one condition alpha beta are equal to 1 for turbulent flow. Okay, next thing is that generally generally beta is more than 0.5 alpha, means beta is not equal to 0.5 alpha or lesser than that. Beta is generally more than half of alpha. So if beta is more than half of alpha, so beta by alpha will not be equal to 0.5, it will be more than 0.5. Okay, and beta by alpha will not be greater than 1, it will be less than 1. So beta will also be less than alpha. Generally, only one condition it is equal to alpha for turbulent flow. For turbulent flow, beta and alpha are equal. Generally, beta ranges from, I will write down like this, beta ranges from 0.5 alpha to alpha. The range of the beta is generally 0.5 alpha to beta. So 0.5 alpha to alpha. So beta by alpha will be in between 0.5 to 1, beta by alpha. Momentum correction factor by energy correction factor means beta by alpha, 0.5 to 1. Only one option is between 0.5 to 1, that is C part. Because this is 1.5, this is 0.5, this is 1. So it is generally not 1. This ratio is only 1 for the turbulent flow. For laminar flow, it is not there. And for laminar flow, if you know the values, you can also give the answer. The value of alpha is 2 and the value of beta is, I think, 1.33. If I'm not wrong, it is 1.33. You can also write down like this. So 2 upon 1.33 is how much? 4 by 3. So 4 by 3 upon 2 is 2 by 3. 4 by 3 upon 2, or we can say also 4 by 3. So 4 by 3 is beta, so 4 by 3 upon 2 is 2 by 3. So from here you can also calculate. And for turbulent flows, alpha is nearly equal to beta is nearly equal to 1. Only for this thing they are equal. The ratio is 1. But here the answer will be C part. So why you guys have given B part? C part is the correct answer. Why you guys have given B part? Momentum correction factor to kinetic energy correction factor it is asked. Beta is always lesser. A lot of students have given B part, but C is correct. Yusuf Bridges have given. This is the leaderboard. Manoj, Nagraj, Vinay, Ritika, Yusuf, Swagatam. And overall, how many students are giving? 48 students. Okay, very good. Let us move towards the next question. Let us see what are the next question. Okay, this is a very good question. These type of questions are generally expected because a lot of tough questions are also there, but they are not expected every year. Every year, some very easy questions are expected. They are repeated. Tough questions are always new. Tough questions are generally not repeated. Tough questions are always new. In the GATE exam, if any tough question has come, this is always new. But some easy questions, some very basic questions are continuously repeated. Okay, and for that tough questions also we are going to do Mahabhyas at 7 p.m. This is the question: water flows through a 100 mm diameter pipe with a velocity of 0.015 meter per second. The kinematic viscosity of water is this much. Now it is asking friction factor of the pipe material is. Now first of all, you have to know what is the Reynolds number, because based on the Reynolds number you will apply the formula. Okay, so first apply the formula. This is again for 1 mark. Some numerical questions I am also giving you, whether for 1 mark or 2 marks, doesn't matter, but these are the numerical questions. So it is a 1 mark question. Even then I am giving you 90 seconds because it is lengthy. Okay, 120 seconds I am giving because it is lengthy. First you have to calculate Reynolds number, then you will calculate F. So solve this and then we will discuss. 4 to 5 questions we are also going to do more. Guys, give me 1 minute more. I am some in middle of something. Okay guys, let's see the solution of this question. So first of all, we will calculate the Reynolds number RE. I think you guys have solved this. So Reynolds number will be equal to, actually kinematic viscosity is given, so directly we'll write down the formula of V into the diameter D upon kinematic viscosity nu. So velocity is how much? 0.015 into diameter is 100 mm, means 0.1 meter, upon kinematic viscosity 1.13 into 10 raised to power minus 6. From here we will get the RE value. It is coming out to be 1327.433. This is less than 2000. In pipe flow, if Reynolds number is less than 2000, the flow is laminar. If it is more than 2000, we generally take it as turbulent. Generally we take for 4000 more than, but if it is more than 2000, we will apply the turbulent formula. So for laminar flow, the friction factor F, Darcy friction factor F is 64 by RE, and the fanning friction factor is 16 by RE. Okay, but Darcy friction factor is 64 by RE. So 64 upon friction factor means Darcy friction factor. If nothing is written, it means Darcy friction factor. If it is clearly written fanning friction factor, then that is 16 by RE. But here nothing is written, so we will consider that as Darcy friction factor. This is coming out to be 0.048. The correct answer of this question will be D part, as everybody is giving also. D part is the correct answer of this question. Okay, let's move towards the next question. Let us do some questions of the pipe flow also. Let us do some questions of the pipe flow also. Okay, let us do this question. I have told you now I will solve some branching of pipe questions. So this is the branching of pipe question. Because we don't have much time now, then we are generally not able to solve that lengthy questions, but let us solve this. So how to do these questions and how to solve these questions quickly? I am concerned about this. I am concerned about this thing, how to solve these questions quickly. Here this is a point, junction point, where there is some water level is given. This water level is given. It means that the total head is given here. Why total head is given here? Because here the velocity is having different directions now. So the water will be stagnant. Water will be stagnant means here what head will be there? The datum head 90 meter and the piezometric head. And let us see the piezometric head is given or not, because piezometric, this value is not given. Let us see in the statement if they have given. I think this much is visible to you. This much small font is visible to you. Three reservoir PQ and R are interconnected by a pipe as shown in the figure, not drawn to the scale. Piezometric head at the junction S at the pipe is 100 meter. Okay, it is given. So this is 10 meter actually. If piezometric head is 100 meter now, so this is 10 meter actually. If it is not given, it is 10 meter. Because 90 plus 10, that is 100. Okay, so piezometric head is given. That will be very easy for us. Assume acceleration due to gravity as 9.81 meter per second square. Density of water as 1000. This is not 100, this is 1000 actually. 1000 kilogram per meter cube. The length of the pipe from the junction S to inlet is 180 meter. From the junction S to the inlet of reservoir R. Okay, this length is 180. It is given. This diameter is 30. Okay, given. This diameter is 30 also given. Now, considering the head loss only in friction with the friction factor 0.03 all the pipes, then the height of water level in the lowermost reservoir R in meter round up to the 1 decimal place with respect to the datum is. Now, always understand, if here piezometric head is given, so piezometric head here minus this head loss in this pipe, which is having diameter 45, length 180, is equal to the total head in this reservoir R. So this is very simple, that total head at HS minus head loss in pipe. Which pipe? Let us consider this pipe as 1, this pipe as 2, this pipe as 3. So head loss in pipe 3, HL3, is equal to the total head in this reservoir R, means HR. This is the simple concept. Okay, whatever the total head is at P, HP minus head loss in 1. Always remember, if they are asking HP, so HP minus head loss in 1, HL1, that will be equal to the head at S, HS. Okay, here we are not confirmed. Here this head will be more or this head will be more, that we will only confirm if we know the piezometric head at S. So in this question we know the piezometric head at S, then we can make the equation. But if we don't know the piezometric head S at this, then we are not confirmed whether the flow will go from here to here or from here to here, because this is at lower height. This is at 106, this is at 109. So at the mid reservoir, whether the flow will go from here to here or it will go from here to here, we are not confirmed until and unless we are not given this total head at S. Here we have given this is 90 plus 10 100, this is 106. So here head is more, the flow will go here. If the flow will go here, so HQ, head at Q, that is 106 minus head loss in pipe 2, that will be head at S. Because here it is given that HS is 100 and this is 106. If the total head at S is not given, then we are not sure whether the flow will flow from here to here or S to Q. But this is 100% confirmed that at the top reservoir, the flow will always go down. The flow will always go down. This Q1 will always go down. And at the bottom reservoir, the flow will always be collected. This is always clear. But this is not clear whether the flow will go like this or the flow will go like this. This is not clear until and unless this piezometric head is given. Now here this piezometric head is given. This 100 is lesser than this. Then the flow will go here like this. Q2 will be like this. So equation you can also make that Q1 plus Q2 is equal to Q3. So they are very simple equations. Using these equations you can always solve the question. But in this question you will solve this question only by this equation. This question you will solve only by this equation, only this first equation. Nothing else is required because friction factor is given 0.03, length is given, diameter is given, discharge just you have to calculate. Just you have to calculate the discharge. The remaining thing is given. I think discharge is also given. No, discharge is not given. You have to calculate the discharge. You have to calculate the discharge. If you know the discharge, here the head is HS, here the head you have to calculate. If you know the discharge only, then you can calculate this thing. So discharge you can calculate from here. Q1 plus Q2 is equal to Q3. Okay, solve this. This is a very good question. So always when you are going to solve the branches of pipe questions now, always what you have to do, just you have to make the equations. There 4 equations are important. From here to here, what equation will be there? From here to here, what equation will be there? From here to here, what equation will be there? This is the first equation that we have made. This is the first one. This is the second one for the second pipe. This is the third one for the third pipe, and this is the last equation for the discharge. These 4 equations are always important. Okay. 1, 2, 3 equations are based on the Darcy-Weisbach equation. The 4 equation is based on the continuity equation. 1, 2, 3 are based on the Darcy-Weisbach, and also we can say Bernoulli and Darcy-Weisbach combinedly. Because if we will put HL is equal to FLQ square upon 12.8 d ki power 5, FLQ square upon 12.1 d ki power 5, that will be Darcy-Weisbach. Okay. 1, 2, 3 are the combination of Bernoulli and Darcy-Weisbach. 4 is the continuity equation. That I have told you in the previous class also. Okay, now I am giving you the integer option. You can give me the answer. Give me the answer in integer only. Give me the answer, the nearest integer. Whatever is the nearest integer. Give me the answer in nearest integer. Whatever is the nearest integer, you have to give the answer. Okay. 98, 96, 95, whatever is the nearest integer. So you have 2.5 minutes. Then we will move towards the question of some question of your dimension analysis also. Then we will do some questions of dimension analysis also. Okay, guys, let's solve this. '98. Everybody is saying 98. Everybody is saying 98. 98, 98, 98. The time is also over, so let's solve this. So this Q1 will be equal to how much? This Q1 will be equal to how much? Let us calculate from this equation 1. HP is 109 and HS is 90. So 109 minus 90 is 19. So head loss in 1 is 19. So from that 19 we will calculate this thing. Okay, velocity is given. Okay, diameter and velocity is given. So from diameter and velocity we can also write down. So Q1 is pi by 4 into diameter. 30 means 0.3 square into velocity is given. If this is not given, we can also calculate from this. 90 meter is this, 109 meter is this. So 109 minus 90 is equal to 19. So the head loss here is 19. Head loss is FLQ square upon 12.9 d ki power 5. From that we can also calculate. If this diameter and velocity is not given, then we can also calculate from this. 109 minus 90 is equal to 19. So the head loss in this pipe is 19 meter. So head loss is FLQ square upon 12.1 d ki power 5. From that we can also calculate the Q1 value. The same thing we will get, okay? But here diameter and flow velocity is given, so we will calculate directly here. 2.56. This will be Q1. Plus what is Q2? In pipe 2 the velocity and diameter is given, so pi by 4 into 0.3 square into 1.98. If this was not given, if this flow velocity and diameter was not given, we can again calculate. This is 106, this is 100, so 100 minus 106, 6 meter. 6 meter is the head loss here. That is equal to FLQ square upon 12.1 d ki power 5. From that we can calculate Q2. But here this is given directly, so we are calculating Q3 directly. So what is the value of Q3? Can anybody tell me? What is the value of Q3? Can anybody tell me? What is Q3 coming out to be? Tell me. Now your poll is over. You can tell me now. Poll is over. If you will comment anything, your answer will not change. Don't worry about that. If you will now comment anything, your answer will not change. Don't worry. Tell me what is the value of Q3. Okay, let me calculate. Let me calculate this thing. What is the value of Q3 coming out to be? I think it is coming out to be 0.321. 0.321 it is coming out. 0.321 meter cube per second. Now we have solved this. Now we will use this equation number 3. HS is how much? HS is 90 minus F is 0.3. Yes, 0.03 into length. Length is how much? Third pipe length is 180 into Q square, 0.321 square upon 12.1 into D raised to power 5. What is D? D is 45 centimeters, so 0.45 raised to power 5. That is equal to the head at R, HR. So let us check what is the HR value. 98 point, how much? This is 12.1. $87.52. This is the correct answer. You can give nearly 88. If I'm asking an integer, you can give the answer 88. Okay, you can give the answer 88 because I have asked in integer. So you can give the answer 88. So anybody, if I've given 88, that is correct. But nobody has given in time. The calculation was not lengthy. Why it was not lengthy? Because they have given the velocity and diameter. If they have not given the velocity and diameter, then it was difficult. Then you have to calculate from each equation, you have to calculate Q1 and Q3, Q2 and then add. Then it was lengthy, but here if they have given the value, so this was very easy for you. Okay, let us do some questions of dimension analysis. 2-3 questions we will do from the dimension analysis, then we will end the session. And some questions are remaining. We have not done a lot of questions today. Some questions are remaining. Those questions we will solve in the next session at 7 p.m. So come at 7 p.m. in GATE wala MECE channel. There we will solve some questions. Some more questions of pipe flow we will solve there. Okay, so let us do some question of your dimension analysis. Dimension analysis we will do some question. Okay, let us do this question. This is from your boundary layer theory. So I'm creating the pole. This was for 2 marks. Okay, so I'm creating the pole, but this was a theoretical question because only equations are asked. So I'm giving you 2 minutes for this. 2 minutes are sufficient for this. This is again for 2 marks. Okay, so let's see this question. The drag force on a sphere kept in uniform flow field depends upon the diameter of the sphere, absolutely, flow velocity, flow density, and the dynamic viscosity. The following option represents the non-dimensional parameters which should be used to analyze this problem. So, what are the non-dimensional parameters? First is your drag coefficient. What is drag coefficient? Drag coefficient is actually Fd upon half rho Vd square. Half rho Av square, sorry, rho Vd square, not rho Av square. But drag coefficient is not your dimensionless factor. Drag coefficient is not your dimensionless factor. So we cannot say that this is a dimensionless because drag coefficient also depends upon the Reynolds number. So what we will do, we will make this as dimensionless. So drag force is actually having the unit of what? Newton. So at the bottom, if anything is having Newton unit, so that will be dimensionless. So Vd is not Newton because V is meter per second, it is meter, so this is wrong. Okay. Then Fd upon rho V square d square. Rho is kilogram per meter cube. Okay. Kilogram per meter cube into V square. V square is meter square into second square. So let's say kilogram per meter cube into meter square upon second square into d square. D square is again meter square. So it will be meter square. This will cancel out. This will cancel out. Meter cube. So kilogram meter per second square. Newton is also kilogram meter per second square. Or this is also kilogram meter per second square. So this is dimensionless. No dimension. So this is correct. Rho Vd by mu is Reynolds number, again dimensionless. So this is correct answer. Okay. So CD is drag coefficient, but that is not dimensionless. Then previous question head at S is 100. Yes, it is given na. It is given in the question. You can say the piezometric head at the junction S in the pipes is 100 meter. I have also marked here. I have also make one circle here. In the whole question, I have made one circle here, and that you have also missed. Don't do this thing, dear. If I am making the piezometric head at section, I have made here 100. Here also I have written 90 plus 10. The total head is 100. I have written this. Written here, mark, circle here. How you are getting not getting this? That is 100. Because water will be stagnant, na? So why you take 90? I have done mistake in writing. I have done some mistake in writing. I had done some mistake in writing. That is why. That is why I have written 90. By mistake, I have written down 90. It will be 100. $97.5, so the answer will be 98. Okay. By mistake, I have written down. Simple answer is that. Okay. The answer will be 97.52. Okay, so this is the dimensionless thing. This will not be dimensionless because rho V square d square was dimensionless, so this will not be dimensionless. This is dimensionless, but this is not dimensionless. This is again not dimensionless because here cube is that. Rho Vd by V will be dimensionless. This is correct, but this is not dimensionless. So both are the dimensionless parameter are this. So this is actually from dimension analysis, not from your boundary layer. Again, this question let's do. So B part was correct. This was only for 1 mark. So I will only give you 60 seconds for this. Quickly give me the answer. Relationship between the scale length ratio and the velocity ratio VR in the hydraulic model in the Froude number in dynamic similarity. So what is Froude number? Froude number is actually V divided by root GLC, where LC or L is the characteristic length. But in the Froude model, what happens? In the Froude model, the Froude number of the model will be equal to the Froude number of the prototype. Froude model law says that the Froude number of model should be equal to Froude number of prototype. Means the ratio of the Froude number is equal to 1. So V of model upon root G into L of model is equal to V of prototype, velocity in the flow of prototype is equal to this Vp upon root GLP. So Vm upon Vp will be equal to under root Lm upon Lp. Vm upon Vp is the velocity ratio Vr, Lm upon Lp is the length ratio Lr. So Vr is equal to root Lr. Vr is equal to root Lr. That would be the answer. But what is saying? The velocity scale ratio. Actually, this is not Lr, this is Vr. By mistake they have typed. Typists have also done mistake. This is Vr. This is Vr. This is not LR. VR is equal to root LR. So D will be the correct answer. Okay. D will be the correct answer. Here it is not LR, it is VR actually. Okay, let's move to the next question. 1:50 model is there. What is saying? Acceleration due to gravity, the corresponding discharge due to gravity. So when the gravity is there now, the Froude number of model will be equal to Froude number of prototype, because gravity is there, so Froude model law is applicable. And when we have done this in the previous question, we have got VR is equal to root LR, means velocity ratio is the length ratio. So what will the discharge ratio? So from here, discharge ratio will be equal to area ratio into velocity ratio, because discharge is area into velocity. So discharge ratio will be area into velocity ratio. What is area? Area is actually dimension is square. So area ratio will be equal to LR square, and length ratio we have calculated root LR. So LR into root LR, LR raised to power 2.5. So always remember, in Froude's model law, the discharge ratio is LR raised to power 2.5. So we can solve this question now. I'm giving you 90 seconds. Sorry, I have to stop this poll because by mistake I have taken that poll. Integer type I have to give. So give me the answer 2 digits after decimal. No, integer. You can give me the answer in integer because it is discharge now. So you can give me the answer in integer. So give me the answer in integer. Here, give me the answer in integer. Quickly give me the answer in integer. After that, we will do one more question and then I will end the session. So discharge in model is given or prototype is given? The discharge in the prototype is given. So Q of model upon Q of prototype is 1000 is equal to LR raised to power 2.5. Length ratio is 1 upon 50. So 1 upon 50 raised to power 2.5. So from here we will get Q of model is equal to 1000 upon 50 raised to power 2.5. So you cannot give the answer in integer. Give me the answer in 2 digits after decimal because it will not come in integer. 2 digits after decimal. Give me the answer 2 digits after decimal because it will be very small value, no? Give me the answer 2 digits after decimal. Please correct your answer to 2 digits after decimal because this will be very small. This value will be very small. So if anybody has given an integer, give me the answer to 2 digits after decimal. If anybody has given an integer, please correct and again comment 2 digits after decimal. So 1000 divided by 50 raised to the power 2.5, that will be 0.566. So 0.56 we will give answer. 0.56. 0.57 is also correct, but I will only give one answer now. So 0.5. 0.056, sorry. Actually, whenever we are doing anything now very fast, though, that will be very wrong. So 0.056, nearly we can say 0.06. Whenever I am giving answer fast now, there will be some mistake. So I have corrected it 0.056, okay, not 0.56. That will be 0.056. So 0.06 will be the answer. Okay, let us do this question. In a laboratory flow experiment, it is performed over a hydraulic structure. Again, hydraulic structure means again the Froude's law. The discharge and the velocity are 0.05 meter cube per second and 0.25 meter per second respectively. Okay. Okay. In a laboratory means in the model. This is in the model. In the lab, there is a model. Variation of acceleration neglected means gravity is taken same for model and prototype, because the gravity for the model and the gravity for the prototype is same if we are testing both in a same planet. Now suppose we have to make a hydraulic structure in moon. Suppose we have found water at moon. We have found water at moon and we have to make a hydraulic structure at moon. But we are testing its model at Earth. So we have to take the G for the prototype as G at moon, that is G by 6, and for the model we have to take gravity as G. That is why it is written that if the planets are different or the gravity is different, suppose you have to make the hydraulic structure near equator G is different, or you have to make the hydraulic structure near pole and you are testing near equator. So at equator the gravity is different and near the poles the gravity is different. You have to make the hydraulic structure near the pole and the model is tested near the equator, the lab is near the equator, or the lab is at pole and the structure is at equator. So there is some variation in gravity. So that variation we have neglected. That is the meaning. Are you getting, Yusuf? Are you getting my point? So on the earth itself also the variation of gravity is there. So where the lab is there, whatever the gravity is there, where the structure is there, there will be some change in the gravity. Because at equator the radius is more, the gravity is lesser at equator. At poles the gravity, the radius is lesser, so gravity is more at the poles. So please understand these things. So as the variation is not that much, then we are neglecting. Okay, so for the model it is given the full scale structure 30 times bigger, means the length ratio is 1:50 because it is bigger na. If the prototype is bigger, so the length ratio will be lesser than 1. It is 1/30. Is subjected to discharge 270. So discharge in the prototype is 270. Then the time scale model of up to 2 decimal places. Time scale means we know that the velocity ratio is root LR. What is velocity ratio? Velocity ratio is actually length ratio upon time ratio, because velocity is length upon time is equal to root LR. So what will be the time ratio here? Time ratio will be again LR by root LR. This root LR will come down. So this will be again root LR. So in Froudy's model law, the time ratio is also root LR. Okay, so that time ratio it is asking. So I am again giving you integer type poll. 90 seconds. Give me the answer. The time for prototype is time we can calculate for the prototype. TR they are asking. Only time scale there. TR they are asking only. So TR will be how much? TR will be root LR. So that will be only TR they are asking. So that will be 1 upon under root 1 upon 30. They are only asking the time scale. So they are only asking the time scale, TR value only asking. So that will be 0.183, 0.1825. So we will give the answer as 0.18. We'll give answer as 0.18. Only the time ratio they are asking. So 0.18 will be the answer. Please give the answer so that we can see the poll. So these were all the questions. I think I have solved around 23-24 questions today. 23-24 questions I have done today. Now we will meet at 7 p.m. So same 20 to 30, any number of questions between 20 to 30 we will solve at the 7 p.m. also. So overall you will be having 40 to 50 questions. Around 40 to 50. Any value between 40 to 50 questions you will be having. Okay. So that's all for now. Now we will meet at 7 p.m. and let me show you the leaderboard. Let me show you the leaderboard. Nagraj, Vinay, Manoj, they are the top 3 students. Then Ritika, Yusuf, Swagatam, and overall 48 students have given the answer in the whole session. The top 10 students are Nagraj, Vinay, Manoj, Ritika, Yusuf. Top 5, congratulations. Then from 6, Swagatam, Brajesh, Suraj, Nitin, Akansha. They are the top 10 students. I can also start the video call with anyone, but I don't know you are able to receive the video call. That is why I am not starting the video call. Otherwise, generally for the first student, I start the video call and I discuss that whatever your experience is there. But sometimes the students are not comfortable. That is why I am not starting this. So in Telegram, if you are not there in my group, Telegram group, you can join my Telegram official group. The group name is Shobhit Sir PW. You can join my group. You can ask anything if you want to ask. Anything if you want to ask, you can ask. Okay, that is the thing. If you want to ask anything, you can ask directly. Okay, this is the thing for today's class. So I think that's all for today. Thank you guys for joining. We will meet at 7 p.m. and at 7 p.m. we will continue. So bye bye. Take care and take a very good care of yourself and your health, because before the exam, just before the exam, your health should be sound enough. Don't be in the trap of the cold waves or anything like that, because the season is very changing, very rapidly changing. So don't come in that. Take proper meal, take proper care of yourself, because just before exam, if you will get anything like that, then that will be very enormously what I will say impacting for you. Okay, so that's all for now. Let's meet at 7 p.m. in the different platform, different channel, GATE wala MECEXZ. And till then, bye bye, take care, thank you, Jai Hind.